Hi, welcome to another video of World of Engineering. Today I'm gonna just take you through this portable speaker that I'm going to make. It's a small project. Zoom out a bit. I put a small block diagram first so I can explain what would be the design, and then I'll show you the components and equipment I'm going to use. So starting from the top, as you can see, I'm going to put two lithium ion batteries, and what I'm using for this project is two of these Panasonic one, and I can tell you this is the most expensive bit of this project. Each of them would cost $10 to $15 to purchase, but it's worth it. I've got another video on expensive batteries versus cheap one, and what are the drawbacks on them. So that's the one I'm gonna use with two of these battery holders. I'm gonna put them together, and they will be in parallel. And this rated voltage is 3.7 on these. Get this focused. These two batteries are connected to my charger, which has a micro USB input, which I can charge it with any micro USB these days. This is standard, and this is the module I'm using there. It's focused, and this is a TP4056. There are plenty of reviews on that, and with that, the good thing about it is it has a separate output for the load and the battery, and as I drawn here. So then there's a negative output separately, which then I connected to my load, and my load being the whole system. Zooming out a bit. Alright, and then from here, that goes, I've got a switch on my negative terminal there, and then it goes through a boost converter. And this boost converter, I'm using this one. It's another famous, there's some reviews on it as well. I got a review on it as well if you want to watch it. It's XL6009, and so the voltage here, it's about 3.7 volt, and then a better marker, and then this boost converter will give me 5 volt DC. And I converted it to 5 volt because I'm going to use this portable speaker also as a USB charger for mobile phone as well. So that will straight goes to a USB output, which I just bought one of these USB PCB mounts. You can buy from eBay like for 50 cents something, and then I mount it on a PCB. Put this here, and from here 5 volt output also will go through my Bluetooth zoom out a bit that way, Bluetooth receiver, and I've got another negative switch on my negative to just turn my Bluetooth on and off whenever I want it. And from this 5 volt booster, there's another output which goes through the amplifiers, and I'm using 2 amplifiers, and that's what I already connected the wires to it. That's why it is pretty small. It's a PAM 8403. I'm using 2 of these. So I'm gonna get 2 stereo and 1 mono, and why I'm doing that, because the mono one, this is the speaker I'm using, is quite big, so I'm gonna put some sort of filter on it and some sort of low pass filter, because it's a bigger speaker. It can produce the lower frequency better. And the stereo output, I'm using these speakers. These are out of my, I had an old laptop, got it out of it, and I'm using a lot of actually recycled stuff. I'll take you through it. So these are the speakers. I'm gonna put there, and also down here, zoom out a bit. I got a 3.5 millimeter input as well. So when I turn my by Bluetooth off, I can feed straight to the amplifiers, both of them, with no, I don't need wireless, just there. So just going briefly over the block diagram and the design. I got switches here, the 3 switches. So that this switch will kill the power to the whole circuit, and when you close that, your booster is on, so you can charge if you want. And if you want to turn your amplifier, zoom out a bit, you close switch 3 here, get these 2 powered. Again, I got all my switches on a negative terminal. And if you want to use Bluetooth, you use switch 2. Here, the battery is connected to this charger with no switch, because this charger itself has a few protection. That's protection. That's we've got a low voltage protection to protect the batteries. So I think if the voltage goes below 3 volts, this thing will basically kill the load and stop the battery draining. So you can protect your battery from destroying the batteries. And also it has a few other protections, and it has almost zero current draw on the batteries when it's connected. It's a very smart charger. And that's what else. For the box, I'm using this. Zoom out a bit. It's as you can see, it's a tea box. A friend of mine gave that to me. It's wooden. I told him no, I can use it. So I'm gonna put everything here, and everything will fit there actually very easily. And then I've got this grill out of a fan, a computer fan. Did a few bends. So I bent it, and so it will fit here. And what else? I got my switches out of a USB 3 which I bought some time ago, and it was useless, the USB 3 I bought. I mean, if you look at the switch, you might recognize the USB 3, which is very common on eBay. It's a USB 3 hub. It comes with these switches. You can turn off every USB. It has 4 inputs. It's a massive switch. It's nice and small and beautiful, but you know, it's not designed obviously for that application. Yeah, it's rated 250 volt, 3 amps. You know, so you can handle quite a current. So I'm using these. What else? I think yeah, that's about it. I'll go through the build. So that's the receiver, and this one actually I bought this from eBay. Okay, focused. So this is one of the Bluetooth receivers that come in a USB package. So I just opened the package, and as you can see, the USB thing is still there, and 5 volt will fit into that. I got a boost charger to make it 5 volt. So boost converter to make it 5 volt, because these amps, PAM8403, they are more efficient and have less noise at 5 volt. You can run them at 3.3 volt as well. So I could actually run the amplifier using the batteries directly without this boost converter. But using this first enables me to charge devices with the system, and also run the amplifier with less harmonics and noise. Alright, I marked where I want to make the holes for the switches and the USB and the micro USB, and I'm going to use the fret saw to cut these out from this wooden box. So after you mark where you want to make your cuts, the way you use your fret saw, you drill some holes in the middle of those areas. So that's what I want to cut out, and drill a hole here in the middle. And with fret saw, basically you need to open that. It's very tiny blade, and you just put it in here like that, and then you need to tighten it. It's quite tricky. I mean, there are other ways to do it as well, but I just prefer this one. And with fret saw, you need to basically put some pressure on this when you close it, and then tighten the blades. Alright, I sanded the box and made some hole in front for the switches and the USBs and chargers, whatnot. And so all those marks and T marks are gone. Looks better. Also applied wood glue to reinforce it, just all corners. Put these clamps on, and the wood feels like balsa, but it's harder than balsa wood. I'm not sure what it is. Alright, I'm almost done with the build. So as you can see, everything is in. It's a bit messy, the wires. I try to tie it up, but I mean, I think that's as best as it gets. So a few modifications I did as I was going through the build. So with these speakers, I noticed with the speaker itself, by itself, I'm mounting it on some sort of grid or some plate like that. It's not gonna have like that loud voice. So I thought I can come up with a box, and the best thing I could find was using the silicone tape, which is this, and wrap this around it and make some sort of enclosure for it, and that kind of amplified the sound almost, I can tell you, twice. That was really good. And with this speaker, I found these this one for it, which was the original casing of that speaker, and that's basically increased the bass. And what I noticed is if I close this bit at the end, it again increases the bass sound again. So I'm going to put some sort of duct tape or something on it with a bit of super glue, and we just make it a very small hole on the back, and that would again increase the bass. So because this speaker will give me the bass, and this one will give me my mid-range and like basically tweeters. Alright, so the speaker is completed, it's done. A few learning tips or things that I learned through was building this up. As I mentioned earlier, looking at the schematic here, for all the switches I placed them all on the negative side, that this one and that one in here. The issue with that was because each of these boards, the negative, it's not isolated. For example, the ground output of this Bluetooth is common with the negative of that, and similar to here as well. The ground of this amplifier, it is common to the negative power supply. So basically, it means if even this amplifier, if it's even off, if this switch is open and this Bluetooth is on, this amplifier will turn on as well, because it established a path through this negative here and then through the ground and through there. So that was the issue. So to address this, basically you need to put all the switches back on positive. And the reason that initially I did that, put on negative, because I seen some application that for switching in DC they put the fuses or switches on negative side. But obviously in this case, because our circuits are not isolated, basically the output and input, that creates the issue. And this is my end product. It really looks nice. It's got a very natural feel into it because of the wood, and I think it's balsa wood. It looks like a balsa wood. This bit here, this bit is metal mesh, and it's pretty loud, the speakers. So basically from here you can charge your phone. This is a 3.5mm input, and that's how you charge this in here. This switch is to power the booster on, which is that, and the middle switch is for the Bluetooth. Just let me turn it on, and that's how it feels. And the one on the right is for the amplifiers. I'll try to connect it with my phone. Right, so it's connected. That's how it sounds. The bass is not very strong, but the lower and the beats and the trips are very crisp. Because to get a very good bass with these sort of speakers and portable speakers, you need to design all the sizing and the speaker size with do the calculation like a subwoofer to get a very good sound output. But I mean, it's nice. So what I'm going to also do, test the power output of the charging. So I just insert this power meter. Can you see the value? We got just insert that. So it's at 5 volts. I'm just going to plug in my LG G3 phone. It's charging. Let's see. No, not yet. Now it's charging. And it's drawing 0.7 amp, which is 0.8, which is good. Obviously it's not 2 amp charger, but it's about an amp charging. And I got 2 Panasonic batteries inside, each about 3000 milliamp. Alright, thank you for watching, and make sure you subscribe and click like. Thanks.